Welcome back. Let's go ahead and continue our discussion on limits. More specifically is, what is the truest definition of a limit? In order for a limit to exist, now this is our rule. This is the only rule for limits. This is the rule for limits. For a limit to exist, we need to look at both sides of the x value. This is called taking the right hand and the left hand limits. Notice, let's take a look at our function right here. For the function y equals f of x, the value at x equals 2 does not exist. There's a hole there, dear Liza. So we know the value at 2 does not exist. And that's how we are going to write it, D and E. All right, D and E. That does not mean, though, that the limit does not exist. Recall from the first video, the limit only asks what the values of the function are approaching. But we must look at both sides of the x value. So if I look over here, here's my x value. There's my limit that I'm looking for, x equals 2. If I look at both sides of the function, I have to look at the right side of that limit. The left side of that limit, and I have to look at the right side of that limit. And I have to find out what's happening to the function. What are both sides approaching? For example, if I go on the left side, the function is going down as I head to x equals 2. This is called the left hand limit. If I look at the right side, it looks like the function's going up from the right. So we call that the right hand limit. We have a special notation. Now, we talked earlier about the notation for the limit, but here what I want you guys to notice, when we talk about the left hand limit, we have this little negative sign superscripted above the 2 there. This is considered what's called the left side. And if we look at the graph here, what that's telling me to do is I want to look at only the left side. As I head to x equals 2, remember we're always heading towards the c value, the x equals 2 here. So as we head to x equals 2, what is the value of the function getting closer to? Well, it's going down from 10 up here. It looks like it's going down all the way to 4. So we say the left hand limit is 4. Now, the right hand limit, we do the same thing, but from the opposite side. From the right, we're starting way down here, and we're heading up the function here. And it looks like here again, we're also heading to 4. Now, these are not typically limits, considered limits. These are what we call single-sided limits. And again, if you have a minus sign up here, it's the left hand. Now the right hand limit, I didn't say this beforehand, but if you notice there's a little bit of a plus sign right here. That is talking about the right side. These are called single-sided limits. We need both of these to determine if the limit exists. And since they are both the same, we can actually say the limit as x approaches 2, notice no superscripts here, that the limit as x approaches 2 is 4, because both go to 4 in this case. They both head to 4. This is sometimes referred to as the actual limit because I looked at both the right and the left hand side. Now, very important, this is just a reiteration. The limit exists only if the left hand and the right hand are the same. In other words, here's how we would write it. The limit as x approaches c from the left is equal to the limit as x approaches c from the right. Then the actual limit must exist. For example, up here, we would write our answer as the limit as x approaches 2 of our function, you always need to have this, is 4. And that is because the limit as x approaches 2 from the left of the function equals the limit as x approaches 2 from the right of our function. And that is how we would write our answer right there. Okay? And you're going to see that in my notes and in my homework and in everything else, because that's how we have to write our answer every time. Get used to a lot of writing in here. So let's take a look at another example here real quick. Here we go. Alright. Use the graph below to answer the following question. So let's take a look at these. These are not too hard to do. Now, so we have this weird looking function right here. So we want to determine what is f of negative 3. Now, of course, we know that this is talking about the value. And if we go to negative 3, right there, it looks like the value is 0. Now, the next question says, what is the limit as x approaches negative 3 from the left? Remember, this is from the left. Now, it's asking if we approach negative 3 from the left side. Now, don't worry about over here. Remember, limits are really close. I mean, it's like, if we're talking negative 3, we're talking negative 3.000000001. We're talking close. How close? Ready? Close. Okay? So when we talk limits, when we're looking at the limits, x approaches negative 3 from the left, we're not talking about negative 6, negative 5, negative 4. We're talking close, okay? Like touching it almost, okay? Really close. So as we approach negative 3 from the left, what's going to happen is, well, we're approaching 0. And so we would write out the limit as x approaches negative 3 from the left of our function, need to have that, is 0. Now, the next question says, what if we approach negative 3 from the right? Well, it's the same idea. Here's negative 3 from the right. We're also approaching 0. Now, remember, these are single-sided limits. All the single-sided, right? You can sing a song there. And then question 4 says, what is the limit as x approaches negative 3 itself? Well, for this one, we need to look at the left and right. If we look at the left and right hand limits, we can see they both equal 0. They are the same. And because of the same, we can say the actual limit here is 0. Now, we don't just say 0, we should always write the reason too, because the limit as x approaches negative 3 from the right, left of our function, equals, ran out of room here, the limit as x approaches negative 3 from the right of our function. And so that would be our actual limit. So let's try number 5, 6, 7, 8. Well, how can we dance? 5, 6, 7, 8. Alright, so number 5. The limit as x approaches negative 5 from the left. If we approach negative 5 from the left, now take a look here. This is what I'm looking at, this little piece right here. Right away we know it's a lot different than we had at negative 3. If we approach negative 5 from the left side, what is it we are approaching? Remember, we're looking only at the left. We are approaching, it looks to be at negative 1. What about the limit as we approach negative 5 from the right side? Well, from the right side, looks like we're approaching the x-axis, or 0. So next question says, well, what is the actual limit? What's the actual limit? Well, these are different. They're not the same. We're not approaching the same value. So what's that telling me about the limit itself? It does not exist, because they're not the same. My left and the right hand aren't the same. You want to think of a limit as like a gigantic car crash. You have one car here on the left, one car here on the right, and they want to head toward each other, and you want them to crash. Okay? So you want that intersection. You want them to meet. The left hand and the right hand, you want them to meet. You don't want to do something like this. In that case, the limit itself does not exist. Imagine walking down the hallway, and you want to give somebody a high five. Hey man, give me a high five. Not now, it's coronavirus. Oh, hey man, give me a fist bump. Okay. Whoop. You don't want that. You don't want that miss. Okay. Because the limit won't exist. You want this. Fist bump. You want them to intersect. So if the limit does not exist, we have to write a reason. In this case, it's simple. Because the limit as x approaches negative 5 from the left of our function does not equal the limit as x approaches negative 5 from the right of our function. It is a lot of writing. I agree with you. Okay, it's a lot of writing, but you got to write it. If you want to get a good grade on that AP, and you all can, you got to show your work. That's really what they want to see. This is understanding, checking for understanding. That's really what they want. All right, question 8 says, what's the value at -5? Well, it does have a value. It is -1. Now, the next question is kind of interesting. We talked about this. Is the function continuous at -5? Remember we talked about, if we turn over to this page over here, we talked about continuity. It says if the limit and the value are the same, we call it continuous. So at -5, my value is -1, but my limit does not exist. So the answer is no. And the very simple reason for now is that the limit does not equal the value. We're going to get more specific about that later on. Well, what about at -3? Well, let's take a look here at -3. We know the value is 0. The value is 0 and the limit was 0. So yeah, this is continuous. And that is because the limit equals the value. Again, later on we'll talk about how we really write that. Alright, try one your own. Is the function continuous at -2? Pause it. Well, I'll stop for a second. Is the value continuous at -2? And you should have got no. What's the limit as x approaches -2 of the function? Well, look here. From the right side and the left side, we're approaching -1. It's approaching -1. It's like, here's the cars. We're heading toward each other. But look, there's a hole there. A miracle occurred, and one got transported here to -2, because that's the value. F of -2 is -2. They are not equal. And because they're not the same, we say that those are not continuous. All right. Last one. Pause the video here. Try this one out. Number 12 here. Try this out. And I'm going to go over it now, but go and pause the video if you need to. We want to find the limit as x approaches -2. Again, from the left. From the left at -2, I'm sorry. We are approaching 1, 2, 3. From the right side, we're also approaching, we're not approaching 3, we're approaching what? From the left, we are approaching 1, and from the right, what are we approaching? 1. There we go. So, what's the actual limit? 1, and that is again because the limit as x approaches 2 from the left equals the limit as x approaches 2 from the right of our function. The actual value is 3. Notice the limit and the value are not equal. Therefore, we can say the function, that's what these 3 dots mean if you've ever seen them. Therefore, the function f of x is not continuous at x equals 2. And the reason for that, the value and the limit are not the same. But does it mean that there aren't values per c that aren't continuous? That it will exist? And that's kind of what this question is asking. And it says identify the value of c for which the limit exists. Well, the only place the limit, that's a tough one. This is a really good question right here. Are there values for where the limit exists? Now, notice this is not the value. Okay, be very careful. So if I take a look here, will the limit exist at this point? This is a tricky question right here. Yeah, I'm approaching a point there. Well, what about here? This is the only weird one. This is the oddball. Okay? We can say that the limit, we can already say that the limit exists everywhere. Exists everywhere. Right? We can already say that. The limit exists everywhere. The only place we really have to check is where we have our hole. That's the only place we have to check. It's the oddball. So I just have to say, well, does the limit exist here? And I would say, yes, it does, because from both sides, we're approaching 1. So the limit does exist here at x equals 2. We already know that because we set it for part C right here. So is there any place where the limit does not exist? And the answer is no. There aren't any places. Now, we're not talking about the value. Be careful. If I say the value, we can say the value does not exist at x equals 2. But that has nothing to do with the limit. Limits and values really don't have anything to do with each other. We're going to spend some time this year talking about those, okay? So I hope you enjoyed the video, and I will see you guys next lesson.